Oh, yep, I did that.
Yeah, okay. So, we're dealing with similarity issues and linear ratios, area ratios, and volume ratios, right?
Yeah.
Okay. If you start off every single problem you have that is involving linear, area, and volume by writing these three things in this order, you'll have no problem solving any of these problems.
Okay.
Okay? In other words, they usually give you the information that allows you to calculate one of these.
All right.
So if I had a linear ratio of, if I had an area ratio, well, I saw one that I kind of liked. You've probably seen this one. That's the area ratio. They give us that.
Okay.
What's the linear ratio?
Wouldn't it be those squared? Would it be 98 and 2 squared?
It's the square root.
Oh, the square
In
root.
other words, area ratio is always the square of the linear ratio. Volume ratio is always the cube of the linear ratio.
Okay.
Okay? So immediately I could say, well, that's got to be the square root of 98 over the square root of 2. But notice there's a little bit better way to do it. Let's reduce the 98 to 2. What is that?
49 over 1.
And now what's the square root of 49?
Let me see. Okay.
You probably should, you want to memorize your perfect square numbers.
Okay.
Just because you have to be able to do this so frequently with perfect square numbers that you don't want to have to use a calculator every time.
Yeah.
What's the square root of 49?
7.
So that's the linear ratio. And I can put a 1 under it if you like, but I don't really need to.
Okay.
In other words, I can leave it as 7, just like I left this as 49, not 49 to 1. Now, notice that if I do it the more straightforward way, to get that,
Yeah.
well, the numerator becomes 7 root 2 divided by root 2. The root 2's cancel, and I get my 7 to 1 either way. It's just a little bit easier if you reduce this to the number 49 right away.
Okay, that makes sense.
Okay. But either way, there's always, a bunch of ways to do these problems. And so what's the volume ratio going to be?
So it would be 7 or 49 cubed or 7 cubed.
Go straight from that. In other words,
okay.
Don't relate it to the area ratio.
Okay.
Because technically it's the area ratio to the 3/2. But the reason you want to start out all problems with doing all three of these is because this is the square of that and this is the cube of that.
Okay, that makes sense.
So once you get one of them, you can figure out the other two. And a lot of the problems, you don't need both the other two. They may give you the area ratio and ask about a linear ratio. So we don't even need the volume ratio. So you don't always need to fill in each of these.
Okay.
But it's not a bad idea because it's so easy to do. In other words, once you get the linear ratio, getting the area ratio and the volume ratio is a piece of cake at that point.
Mm-hmm.
And I'm a pretty firm believer that you should always do big to small, not small to big.
Yeah.
I don't know what your teacher, he advises small to big, I believe.
Yeah, I mean, I asked him if I could, like, switch it around, and he said it was fine.
Good. The reason it's good is because when we take square roots of numbers greater than 1, they get smaller. If we're doing small to big, and we had this ratio, that's going to be like 0.02. Now we got to take the square root of that, and the number actually gets bigger. So
Okay.
it's far more confusing when you're doing small to big.
Yeah.
Because the numbers are always less than 1. And taking square roots and cubing and cube roots and all of that is much harder. It's more confusing when the numbers are less than 1. Whereas it's not confusing at all if the numbers are greater than 1. I know when I take the square root of 49, it's going to be bigger than 1 and less than 49.
Yeah.
So I'm going to get 7, and then I'm going to cube 7. It's going to be 7 times 7 times 7. So I don't have to deal with any of these decimals that present confusion.
Okay.
Get the same answer, but I definitely am a huge believer that big to little works better than little to big.
Okay.
Now, the only other type problem you're dealing with besides these ratios is similarity. Let's talk about similarity for a moment. The biggest thing about similarity that can be confusing is these ratios work all kinds of different ways. In other words, these two triangles are similar, which means 10 is to 5 as 12 is to 6. Okay? That's the typical way we do it. We compare corresponding sides of the similar triangles. Well, if that side is corresponding with that side, and that has to be the same ratio as that side is with that side. But what's confusing is that the ratios within are also valid. In other words, I can say 5 is to 7 just within this triangle has to be the same ratio as 10 is to 14.
Okay.
So the ratios kind of work from one triangle to another, and they also work within one triangle, as long as you can find the same corresponding sides. This side is to this side as this side is to that side.
Okay.
That's really it. That should cover every single thing that you just have been quizzed upon.
Mm-hmm.
Do you have some specific problems?
Yeah, so I sent you, did you get the email that I sent you?
What is with the emails that you and Dylan try to send me? I don't get them. What is going on? Well, did you send it to David Cowan, or did you send it to David at Digital Math Tutor?
No, I sent it to David Cowan. I see it. It's a little from the bottom. It's.
Oh.
It's.
Yes, I see it also. Yeah. And for some reason, all of a sudden, oh, there it is. Oh, I already copied this.
Yeah.
Well, that's right. Here's what happened is you sent that to me before my 3:30 appointment, and I used those with my 3:30 appointment.
Oh, okay.
Because he's at Chatfield also. Yeah, this problem you couldn't do because she didn't give you enough information on it.
Yeah, I was really confused. I was like, I think you need at least one more number.
Right. However, it's worth looking at this problem. Because a very interesting thing happens when you take any right triangle. If I take a right triangle and I draw a line perpendicular from the right angle to the other side, I create two triangles that are similar to each other and also similar to the right triangle. In other words, triangle 1 is similar to triangle 2, and both of them are similar to that big triangle.
Okay.
So the difficulty is that they're kind of oriented strange. So it's hard to tell what are the corresponding parts here. But let's look at it anyway. Even though we can't solve this, I can throw in a number that we could solve it. But let's make sure we find out what the corresponding parts are. Okay, there's the right triangle. I'm going to draw a vertex perpendicular to that, making a right angle there. So let's figure out which angle is that?
It's
Let me label them A, B, C, D.
okay. So A is C.
No. And the way you know is that in the big triangle, it's not an isosceles right triangle. So if I'm looking at the big triangle, it's not going to be very often that A is equal to C, right? So when I know that this triangle is similar to this one, it's not A that's equal to C, it's A that's equal to this angle right there.
Okay, so then it'd be B is equal to C.
Well, yeah, not quite B, ABD.
Oh.
In other words, ABD would equal C.
Oh, yeah, that's right.
And once you have it defined like that, now it's easy enough to find corresponding parts. In other words, this hypotenuse, which is 32, and this is the hypotenuse on that little triangle, right?
Yeah.
So those have to be the corresponding parts. You always know the hypotenuses are the corresponding parts. It's sometimes difficult to match up the sides, but now that we've got the angles, I know that DB has to be the corresponding part to which side?
So DB is
Here's the way you figure it out. DB is opposite what?
C.
It's angle C.
Yeah.
So we need to find the side that's opposite that same angle. Well, this was the angle,
Uh-huh.
so it's AD. So
Okay.
AD would be similar to DB. In other words, not equal. I've made the congruency sign there, which is not proper, but they are the corresponding parts.
Yeah.
Okay? And whenever you take this right triangle and divide it up like this, it's always like that. A is never similar to C. It's always this angle that's similar to C, congruent to C, and this angle that's congruent to A. Okay, so is all we need here is a side like 10. Okay, and then the similarity ratio is what?
32 over 24.
And that would be equal to what?
It would be equal to 12 on the bottom and
Well, 10, first of all. In other words, I'm saying the big is to the little. Okay, and then this triangle here is bigger than that triangle, right?
mm-hmm.
So it's as y is to x.
Oh, okay.
In other words, we have found that these are the similar sides, and this is the bigger one. And I can see that just by looking at it.
Yeah.
This triangle is bigger than that triangle. Therefore, if that's the corresponding side, it's that relative to that corresponding side. All right. So if I give you an x or a y, you could solve for the other. And same thing about z.
Mm-hmm.
Z would need a y. All right, let's go to a different page.
I started doing this one, but I got it wrong, so I had to erase it.
Okay. These word problems, they wouldn't be difficult if they just drew the triangles, right?
Yeah.
They're only difficult because they give you a word problem and you have to construct the triangles.
Yeah.
But, so, always make that your first goal. A cliff casts a shadow of 304 feet. Well, there's the 304 feet. Okay.
Okay.
There's the cliff. And here's the sun coming from this direction. That's why it's casting the shadow.
Yeah.
If a 3-foot 9-inch child walks along the shadow of the cliff for 178 feet, so he's walking in this direction for 178 feet, and he finally gets to a point right there, that's 178, and at this point, the tip of his shadow is on the same tip as the cliff shadow. So what can I say about these two triangles?
That they're similar?
Correct. Why? Because they share that angle, and they have two angles that are similar, congruent, excuse me. And two angles is all you need to prove similarity. So what's the ratio I can set up?
304 over 178.
Let's see, this is, how do I switch 3 foot 9 inches? How do I handle that?
Wouldn't you just put it in just inches and not feet?
Well, then I got to switch this 178 feet to inches.
Oh.
So let's leave it in feet, but let's make it 3 3/4. 9 inches is 3/4 of a foot.
Okay.
So that child is 3 3/4 feet, and that way we'll have everything in feet. We could change it to inches. We could have done that, but then I got to change 304 times 12, and I got to do 178 times 12.
Oh, so just be dealing with bigger numbers.
Right. So it's actually easier in this case to deal with a fraction.
Okay.
Okay. Now, what is this length of this small triangle? What's its base?
The base of the smaller triangle? Would be... It wouldn't be a ratio. It would be 304. Wouldn't it be 126?
Uh-huh. So, now you have everything you need to solve for the height of that cliff. What's the ratio? What's the ratios involved?
304 over 126
equals
178 over x.
No. Notice 178 is not the measurement of any of the triangles.
Oh, it would be x over 3/4. 3 3/4.
Over 3 3/4. And the most important thing to do there is to make sure you don't go big to little and then little to big.
Yeah.
Make sure you stay in the same. It doesn't matter. Little to big works just as well as big to little, if you don't mind numbers less than 1. But the biggest mistake you can make is switching them. In other words, if you always go little to big, then clearly the height of the cliff is bigger than the child, so I got to put it in the numerator.
Okay.
And also, how do I solve that now? I notice most of my students making a mistake in solving this.
So it would be 126x
See,
equals...
you don't need to cross multiply.
Oh.
You see why? Let's say we cross multiply. Okay, so we have 126x equals 304 times 3 3/4. What's my next step?
Multiply...
Well, divide by 126.
Oh, yeah.
Okay? So that's a two-step process. But notice what I did. Step 1, I multiplied both sides by 126. Step 2, I divided both sides by 126. It's unnecessary. We don't want to cross-multiply if our variable's in the numerator. We just want to multiply. I'm going to multiply both sides. In other words, x is going to be this ratio times this number.
Okay.
I'm only going to multiply both sides by 3 3/4. When you cross-multiply, you're basically multiplying both sides by 3 1/4, and then you're multiplying both sides by 126. And then you're going to go and divide both sides by 126. So let's avoid the multiplication by 126 that we don't need. In other words, x is going to be 304 over 126 times 3 3/4.
Okay.
Whatever number that is. And granted, this problem is probably one of the more difficult ones to draw the picture properly from the words. I mean, it's just a little confusing. But clearly, once you do draw the picture, you see exactly what's going on.
Yeah.
In other words, this could certainly be a real-life situation. You have a cliff giving a shadow, and you have some kid walking along that shadow until the end of his shadow is the same point as the end of the cliff. That's absolutely something that could happen in reality, and you'd be able to tell the height of the cliff from that information. All right, let's look at 11. We have just about enough time to look at 11.
Okay.
Unfortunately, I have a 7:30. What ratio can I come up with for 11?
Okay, so 11, it would be 37 over 22, no, 37, or 82 over 37?
What's the win ratio if they've won 37 and lost 22? What's the ratio? Is it 37 to 22?
Yeah.
It's 37 to 59.
Oh.
Because it's the number of wins versus the number of games played.
Okay.
And that's the ratio we have to have because they want to know how many wins are we going to have if we play 82 games. So the ratio has to be 37 to 59 is equal to x to 82. If I were to put 37 to 22, now I'm putting wins versus losses, which is a fine ratio, but it doesn't help me any when they tell me I'm going to play 82 games. In other words, I need to figure out how many games we've played.
Okay.
Okay. All right, Kristen. I hope that helps.
It did.
Good luck with your teacher. I have a lot of students with that teacher.
Yeah.
I don't know if that says anything about the teacher or not, but anyway, good luck.
Thank you.
All right, bye-bye.
Bye.